call it as unique address assigned to every devices in the network. Okay, so I have told you what is an IP and what is an IP address. Now we can classify IP address into two, version 4 and version 6 based on its versions. So let me explain the versions of IP address. IPv4 and IPv6. V4 is the oldest one, V6 is the new one. And in V4 we have 32 bits long address, and here we have 128 bits long address. Then address space of this is 2 power 32. This is 2 power 128. So relatively or comparatively, IPv4 can hold only less number of IP addresses. It can hold more number of devices. So when the number of devices in the network increases, IPv4 is not only enough to hold all the devices. So we are going for another one version, that is IPv6. It can accommodate all n number of devices that you need. That is 2 power 128 number of devices you can accommodate inside this addressing mechanism. Now I have to teach you the differences between IPv4 and IPv6. So simply, this is version 4, this is version 6. Then as I told, this is 32 bits long, this is 128 bit long, and this follows dotted representation, and this follows colon representation. An example for this is, and each group has 8 bits, that is 8, 8, 8, 8, 4, 8 are 32. 32 bits together form an IP address. This one group alone is called 8 bit. Likewise, one, two, three, 4, 5, 6, 7, 8. And here 8 groups, and each has 16 bits. That's why, and each group has 16 bits here. Likewise, they have 8 bits. 16 into 8. Together 128 bit long, and this is, most of the times this is represented as binary, this is hexadecimal. And as I told you before, it can have 2 power 32 devices, and it can have 2 power 128 devices. Okay, so I repeat, this is version 4, this is version 6, this is 32 bits long, 28 bits long, and this denotes dotted representation, it denotes colon representation, and here it consists of 4 groups, it consists of 8 groups, and one group consists of 8 bits, the next group consists of 16 bits. This is binary, this is hexadecimal, and here totally we can have 2 power 32 devices, here totally we can have 2 power 128 devices, and we can classify this IPv4 into classful and classless. We can classify this into classful and classless. But in the case of IPv6, there is no classes at all. So next we are going to see the different classes available in IPv4. Here we have 5 classes: Class A, Class B, Class C, Class D and Class E. And probably we will be using these 3 types of classes. We won't be using Class D and Class E. Class D is for multicasting and E is for reserved purposes. So we will be using only 3 types of classes. And again, each class divides its own IP address into 2 different parts. That is host ID and net ID. Just like the analogy that we use in our register numbers. In register number, first few digits may represent the college code, and after that you may fall under to on which year you underwent into that college, and the next few digits will be following your course code, and the remaining would be your register number. Likewise, here the IP address is divided into net ID and host ID. So you already know IPv4 has 4 groups, so I consider them into 4 parts. 1, 2, 3, 4. 4 groups that are equally classified. Each one has 8 bit, 8 bit and 8 bit. Okay. Now, in class A, it can have a large number of devices. That is, it is a large network. Large network in the sense that has many devices, right? Many devices means these 3 portions will represent the host ID. This portion alone represents the net ID. Net ID means to which network it belongs to, and these fields represents the unique ID of the device. Likewise, we have the classification for next class, and here the 3 portions occupied as host ID. Now 2 portion, these 2 will be occupying host ID and these 2 will be occupying net ID. Now the class C portion, here 1 portion will only be using host ID, remaining 3 portions will be used for net ID. Okay, so these portions are called host ID. Remaining portions are called net ID. And this is a large network. This is a small network because you have small number of devices here. Only 2 power 8 devices you can have. But n number of networks you have. And here this is in between both large and small, and this is a large network and it can accommodate 2 power 24 devices in this portion. Okay, now we can classify the classes based on the addresses itself. In class A, the starting address would be from 0 to 127. Okay. Next, here it starts from 128 to 223. This is 191. This is from 192 to 223. Write an example IP address, that is 198.28.18.2. Then from the name itself, that is from the number 198 itself, I can identify that this belongs to class C. Okay, this is class C IP address. That means this portion alone denotes the host ID. The rest of these portions will tell you the net ID. So this is how the classes are maintained: class A, class B, class C, class D and E. D and E we don't use much because it is for multi-cast routing, and this is for reserved. This is reserved for future. And here it starts from 0 to 127, 128 to 191, 192 to 293. So these are the classes we have, and from this example IP address I can identify to which class it belongs to, and from this I can identify that this is the net ID, this is the host ID. And instead of finding like this, we can use another one term called subnet. And the subnet for this is 255.0.0, and for this one is 255.255.0.0, and for this one is 255.255.255.0. So this is literally called net ID, this is host ID, and we can call it as bar 8, and this is called bar 16, and this is called bar 24. Okay, bar 8, bar 16, bar 24. We can call the subnet masking like this, that is 8 bits for networking, 16 bits for networking, and 24 bits for networking. These are all logical representation: 255, 255.255, and 3 255s. So this is called subnet masking. That is, with this number we can conclude how many devices are available in that network and how many bits are used for representing the net ID. Okay. Now this is called classful addressing, and we have another one term called classless addressing. Let me explain you. Now let me explain you. That is classless addressing. This is called classless interdomain routing. So I previously told the first 8 bits or first 16 bits or first 24 bits occupy the net ID. The remaining will be allocated by host ID. I told you. Then what is that fixation? 8, 8, 8. If you have few devices than 8 bits, or if you have more devices than 8 bits, then what will you do? That's a problem there, right? That is fixed. You cannot increase the number of devices. If the number of devices increases, you cannot held yourself inside one class itself, and you have to go for another one class. So if you don't have any class, then you can flexibly manage those things. For example, let me take this number 2, and in this portion 198 itself says that belongs to class C, and this is allocated for the number of, and that is this, all these portions will denote the net ID, and this alone says the host ID. Am I right? And this denotes these many bits are needed to represent a net ID, but only 8 bits are allowed for host ID. Okay. Now in this case, if you have 100 devices, 100 devices means 100, the nearby 2 power number is 2 power 7 is equal to 128. So 7 bits are needed to have or to address 100 devices. Okay, you are in need of only 7 bits. Then what about this extra 1 bit? So that can be given back to here. So we can write this as not 24. Usually we write it as bar 24, but we can write it as 25 because this 8 bit is further classified into 1 plus 7. This 7 is allocated here for this 100 devices. This 1 has been given here. This so flexible flexibility of managing devices. So this is how classless IP addresses are used in IPv4. Then what about IPv6? There is no classes. That is why no need to go for classful or classless addressing. You can simply address and you can give addresses to all the devices as it comes. Okay. So this is all about IPv4 and IPv6. Listen to me. This is IPv4 header format. IPv4 in the sense you will be having 32-bit long address, and this is the header attached to the data. The data is something called payload. So this portion is called header. Okay. Then what is the size of the header? So usually the payload size would be 40 bytes or something else. Then if it is 40 byte, then probably it will be adding 20 bytes, that is extra load to the given data. To the data, you are adding some header. The header is of this format. The first field occupies 4 bits. That denotes the version of the header. This is already known, this is the version 4. The next one, header length. What is the header length? Header length is calculated from this entire portion. What is this? 4 bits, 4 bits, 8 bits, 16 bits. And again, here this is 116 bit. So each row occupied 32 bits. Likewise, you will be having 5 rows. 1, 2, 3, 4, 5. This is optional. This is payload. Okay. Then 32 into 5. So if you multiply 32 into 5, 160. If you divide this by 8, is equal to 20. 8 for bits. So you will be having 20 bytes. That information will be available here. That is, header length is 20 bytes. Then type of service. What type of service is that? Is what is the priority of the packet, or whether it is a congestion notification packet. That information is available. And this denotes total length. Total length in the sense that includes both the header length and also the payload length. Each may be 60 bytes. That is something more than 20 byte. This is 20 byte. This is more than 20 byte. Okay. Now this is a unique ID. This is likewise. If you are a student, you will be having a register number. Likewise, this packet is having a unique ID. That is of 16 bits long. The next, this 0 is already reserved, and this is don't fragment. Fragment means your data will be fragmented and each fragment will be attached to the payload. Don't fragment means this packet should not be splitted further. And more fragments means this is one of the fragments and few more packets are coming and that packets are carrying the rest of the fragments. That's called more fragments. Then fragment offset, that is, if this is the first fragment, then it will be having 1. If it is the 13th fragment, then it will be having the value 13. Likewise, 13 bits are allocated. That many fragments are only allowed. If you have more fragments that you cannot fit the address within this 13 bit means you can create a new packet. We cannot have fragments further. The next one, time to live. Time to live means how long the packet is valid. If the value is given as 5, then if it moves from one router to another router, there it will be reduced to 4. From that to next router, it will be reduced to 3. That to next router, it will be reduced to 2. Then that to next router, it will be reduced to 1. From that to next router, it will be reduced to 0. On getting 0, this packet will be dropped and there is no life for this packet. Okay. Next, this is the protocol. Protocol means what kind of data. Here I have given you the payload, right? This payload will be a TCP packet. So, or UDP packet. Here this information will be available whether it is a TCP packet or UDP packet. The next one is a header checksum. Checksum is a error correction or a reduction mechanism. So, for that a checksum is given and that will be calculated further in the receiver end to check whether the header is modified in between or not. That is a error reduction mechanism. The next, source IP address, from which device you are getting this packet and to which device this packet is to be delivered. This is optional. So this is the overall view of the IPv4. Students, this is about IPv6 header format. Okay. IPv6 in the sense it denotes the header format of the version 6 IP packet. And here this field denotes the version. This field is also similar to the field in IPv4. There also we had the name version that includes the version of the packet. The next one, traffic class. This is something similar to type of services IPv4. Just the change is in the nomenclature, but the remaining explanations are similar. That denotes the type of the entire packet, whether it is a data packet or it is a congestion notification and what is the priority of the packet. All the informations are available here. So these are the things about these two fields. The next field is about flow label. Flow label. This term is something new to IPv6. We don't have flow in IPv4. Flow in the sense this is for flow control, and here all the packets are sent through one flow, and for that we will have a label. So that information will be available. So a number of packets available for that flow, and whether what is the number of this packet in that flow, all the informations are available here. And we'll come to that flow topic in the next class. The next one is payload length. This payload is something called data, that is user data. Then the length of the data is given here. That is, if you have 20 bytes, then 20 bytes will be here. If you have 40 bytes, then 40 bytes will be here. And this is about the next header, that is upcoming packet information. And there in IPv4 we had the fields called more fragments, no fragments, fragment offset, all these informations we had in this location, right? Instead of that fields, we have only one field, that is the next header. What is the next header following this header? That information will be available. The next one is hop limit. Hop limit is something relevant to time to live. There the nomenclature is time to live. Here the nomenclature is hop limit. Hop is jump from one router to another router. How many times the packet can jump without losing its life. So this is the life of the packet. If the value is 5 times it can move, and after 5 iterations it cannot move, the packet become nil. The next one, source address. You all know IPv6 address is of 128 bits, so we have 128 here. This is the destination address, and here 128 bits. This is the payload. Okay. Now we have to calculate entire size of the packet, and here 4 plus 8, 12, and 20. That we can write it as 32. The next, here this is 16, this is 8, this is 8. Totally here also we have 32, and this consists of 128 and this consists of 128. And if you write like this, when we total this, what is the value we get? 20, 2, 6, 8, 10, 12. 320, and this is in bits, so we have to convert this into byte. So if we cross get, then we will get 40 bytes. What is the size of the IPv4? The size of the IPv4 is 20 bytes. So when you take IPv4, it occupies 20 bytes. When you take IPv6, it occupies 40 bytes, and plus payload, that is your data. Here also plus payload. So if the question is asked like this, that is what is the extra overload when we use IPv4 and when we use IPv6? The extra overload is extra header density, that is 20 bytes extra you have to add to each data packet, and here extra 20 bytes you have to add to each data packet. This is all about IPv6 header. So with this I am completing this, that is IP address, its classifications, IPv4 and IPv6 header formats. Okay, and these are all the things we have to learn about IP addresses. Thank you students.